Hello.
Hello, assalamu alaikum. Can you hear me?
Yes, hi. How are you?
Okay, alhamdulillah, I'm fine. And you?
Good, Alhamdulillah.
Okay. So basically, today I will discuss about that land surface temperature. Okay, how we can easily make the land surface temperature map, as well as how we can easily make the change detection. Okay, so all of this process I will show you that one by one and also complete the
Okay,
work.
so today
So
we will start land surface temperature.
yeah, land surface temperature. I talk about that how we can easily make using the
Okay,
Landsat imagery. Okay, so let's go.
okay.
So just I simply share my screen. Can you see my screen now?
Yes, it's coming now. Yeah.
Okay. So this is our main topic about that change detection of land surface temperature, mainly multi-time period, multi-year. Okay, using the Landsat
Yes.
imagery, how we can easily make for the different time period land surface temperature using the Google Earth Engine platform. Okay, and then also make the classification and also make the map. Okay, how much area will be high temperature, low temperature, or very low temperature. So this type of class area we also try to determine for the different time period. So first of all, we have to know about that how we can easily make the LST using Landsat imagery. Okay. So in this time we talk about this algorithm. What is the algorithm? We are used to extract the information of LST or land surface temperature using Landsat imagery. So this is our algorithm about that LST. Mainly here we use here the Landsat imagery. Here you can see the suppose Landsat 8 imagery. After that, the Landsat 8 imagery, we are use here this data OLI,
Mhm.
and then
Yeah.
from here we can get the two band. One band is the near infrared band, another is the red band. Okay,
Yeah.
so near and red we are just make the normalized difference between near band and
Yes.
red band and calculated the NDVI, okay, which is the normalized difference vegetation index.
Mhm.
After that we are just calculated the vegetation proportion, mainly it also call about the fractional vegetation. Okay, so NDVI fractional vegetation equal NDVI minus NDVI mean divided by NDVI max minus NDVI mean whole square. So this is the equation about that. I will show you all of those things one by one. So from the NDVI, we calculated the vegetation proportion or fractional vegetation. After that, from here we can calculate the surface emissivity and also help of the brightness temperature. Okay, so mainly Landsat imagery also provide a band. This band called the thermal band. Okay, and this thermal band mainly it's the band 10 thermal band, and this thermal band help to extract the brightness temperature. And we are using here the thermal band to calculate the surface emissivity. So after calculating the surface emissivity, we are just apply the mono window algorithm and finally calculated the land surface temperature. Okay, so basically this is the algorithm how we can easily use the Landsat imagery to make the land surface temperature map. So now we just try to develop this algorithm in Google Earth Engine platform and then try to make the LST map. Okay, so let's go one by one. I show you that all of those things practically. So let's go. I simply open a new code editor.
Mhm.
Just open a new code editor. So first of all, we have to just import our boundary shape file, Qatar boundary. So just I simply EUSDOS, simply search. It's mainly this is the data set. This data set provide the international country boundary polygon for the whole
Yeah.
world. So just I simply filter this data set and then put the ROI, and then I simply put the table. This table I want to filter I want to filter Earth engine, filter dot equal, and put here that country name. I put the country name Qatar. Okay. So now I display the boundary shape file of Qatar map.at layer and put here the RY and then click to run. So in this time you can see it's add a layer, but don't focus my area. So for that I use here the map.center object and then focus in my study area ROI suppose 10 and click to the run. So now it focus the center of the Qatar boundary, you can see. So now it visualize. So this is my study area. So for this study area, I want to make LST map for the different time period. Okay. So in this time, all of those is the same approach. Okay. So in this time, I will show you 1 year. Suppose year of 2023. You also try to practice for the other year, such as 2013, 2007, or other year. You can also try to practice the same approach. So in this time, I simply select my study area. This is my study area. So now I simply go to the browse data catalog to call the dataset Landsat Imagery. So here you can see the Landsat. Click on the Landsat. So in this time, here I use here the suppose year of 2023. I use here the Landsat 8 Imagery. Okay, for the year of 2023. So click on here. So now it visualizes the different types of images. So mainly we are using the surface reflectance. Okay. So this you can see when I click on the top of atmospheric, you can see what is the difference between that. Top of atmospheric, we don't get any types of brightness temperature band. Okay, brightness temperature band is not available. But when I see, suppose I just simply open this surface reflectance, here I can get the brightness temperature band. You can see, yeah. So this band about that. Okay, so it's called the surface temperature. You can see surface temperature band 10. So surface reflectance image. This is the surface reflectance image. Surface reflectance image only provide the band 10 or surface temperature. So that's why for estimating the LST all time we are using the surface reflectance image all time for calculating the LST. Okay. So this is my image collection. I simply copy it from here. I simply copy. And now I just simply filter this image collection for my study area. Okay. So I simply paste in here and then give a variable name. Suppose I put the variable name, suppose image. And now I filtered it for my study area. So first of all, I simply use here the filter bounds function. Filter bounds with my study area ROI, which studied the Qatar boundary shape file. Then put here the filter date function. I put the date for year of 2023, 1st January from year of 2023. Suppose 11, suppose 20 November. Okay. So now I simply put here that filter metadata for filtering the image properties. So mainly cloud cover less than 1. Okay. And finally I create the median composite, and it also clip with my study area. Study area is that suppose ROI. So now display the result about the image which I get from here. So map.add layer and then put the image, click to run. So now it's added the Landsat 8 satellite image for year of 2023. So we can get this image look like that. Okay. So in this time I add here the visualization. So click on here.
Yeah.
And I had that suppose you can see red band, suppose green band, and blue band or natural color it's called. So now simply set 98% and then apply it. So now we can get the better visualization of this satellite image. So we can get the very better image, you can see. So this is my satellite image I can get for year of 2023. So now I just use this image and then calculated the LST. Okay, so this is mainly land surface temperature. Okay, so how I can do that? So we are just following the algorithm one by one. We just follow. So first of all, suppose I put a suppose layer name. Suppose it's the true color. So true. You can put any name. I put the true color. So now I want to make the LST. So LST, for when you want to make the LST, so first of all, we have to follow our algorithm. So this is our algorithm you can see. So first of all, we need to make the NDVI. Okay.
I
So
think
NDVI we need to create. So let's go. We create
similar way that we did before.
Yes.
Okay.
So in this time I create the LST. So for that I just simply make the NDVI for this study area. So how I can make the NDVI? So I also put the step. Suppose first step, you also
Yeah.
try to follow the all of the system. Then you can easily make the LST of the other year or other previous year. You can easily make same process. The first step, make the NDVI. So make NDVI. So first of all, I create the NDVI. Just take a variable. Suppose I put the variable name is that NDVI. You can put any variable name. So now I want to calculate the NDVI using this satellite image. Okay, which I add in here. And this image is stored in a variable. This is my variable image. Okay. Simply copy and paste here. So now I use a function, normalized difference function. So mainly this function calculated the normalized difference between SRB5 near infrared band and SRB4 red band. Okay. So now we are just use add the map.add layer and add the layer of NDVI map. So NDVI, click to the run. So now you can see it at the NDVI map, but did not put any color. So I want to add here the visualization. Suppose I put here that mean. Suppose put here the mean. It will be suppose put the -1, and then put here the max. Suppose +1, and put here the plated. Suppose I put the plated such as the blue. Then put here the suppose white, and then put here the suppose green color for vegetation, and put the layer name suppose NDVI and click the run. So now you can see it added the NDVI map of your study area. Okay, you can see at the NDVI map we can get the NDVI map look like that. Okay, so after that NDVI, we have to create second step. Second step, we need to create the fractional vegetation. Fractional vegetation. It also called proportional vegetation. You can see our algorithm. Vegetation proportion. Okay, PV.
Yeah.
Or PV. In this time, we calculate the PV. So in this time, what is the formula about the PV? Okay. So if I want to show you from a research paper, suppose I simply open this paper, what is the formula about the PV? Okay, so this it also make about that LST using the Landsat Imagery. So in this time in this paper, you can easily get a lot of information about that. Here you can see from you can see the PV or vegetation proportion obtained according to this formula. Okay, so in this formula mainly it's provide this you can see also put the citation about that. So this is the formula we are used for making the vegetation proportion or fractional vegetation. Mainly this formula, you can see the NDVI minus NDVI mean divided by NDVI max divided by NDVI mean. Also, you can see the whole square. Okay, power 2. So in this time,
Yes.
I need to calculate the fractional vegetation. For that, I need the two value. One is the NDVI mean, another is the
And
NDVI
what?
max. Okay. So
Yeah,
for my
okay.
study area, I need to calculate what is the NDVI minimum value and what is the NDVI maximum value. I need to calculate that.
Mm-hmm.
So let's go calculate for that NDVI mean and NDVI max value. So for that, I just simply take a variable. Suppose I put the variable name is the mean, and then I just simply put here the NDVI dot. In this time, I use here the NDVI reduce region. Okay, so basically this function reduce region calculate any statistical, suppose minimum, maximum, average. It calculate any statistical value for a specific boundary. So in this time, I want to calculate for the Qatar boundary what is the minimum NDVI. Okay, so I simply call this NDVI. So sorry, this is the this variable name NDVI. Use the same. Okay, just paste here. I call the NDVI map and then use here the reduce region. Okay, I put here the reduce region and then calculate all of those arguments. So just press Control and space on your keyboard. You can get all of those arguments. So now just make a dictionary. So use here the curly bracket start and also put here the curly bracket in. So first of all, reducer. So what is the reducer? So mainly reducer is that statistical value. In this time, I want to calculate the minimum value. So use here EE dot reducer dot mean. Okay. Then geometry. Geometry is that mainly for your study area. ROI. Scale. Scale is the resolution. 30-meter resolution. Okay. Then it's not, I simply remove that. It's not need. Okay. So now I simply print that value. Suppose I print what is the minimum value of NDVI for this study area. So now let's check. In this time, you can say I can get this type of problem. It shows that too many pixels in this region. So for that, we have to declare about the max pixel values. Okay, I simply copy the max pixel value from here and then paste here and add the max pixel value. Max pixel value 1E13. So now it will be working. You can see, click to the run again.
What is 1E13?
It means that 1 into 10 to the power 23.
Oh, okay.
It's a scientific notation about that 1E13. 1 into 10 to the power 13. And this max pixel value in this time, it reduce this pixel and then calculate the minimum value of NDVI. Otherwise, it show the problem such as there's a lot of pixel value that exists the limit of the, so that's why it not calculate. In this time it calculate, you can see. In this time you can get the result, you can see this is the
Minus.
minimum NDVI negative 0.264. This is the minimum NDVI. Okay. But in this time here you can say I can get the result as a dictionary. So when I click on here, I can get the result. Okay. But I need only for the value. Okay. I need only for the value. Don't need any types of dictionary. So for that, I just simply use a function. This function, I simply use here the values function. So use here the values, and from the values, I just get, suppose put here the 0. In this time, why I put here the 0? Basically, 0 refers to the first item. Okay. In this time here, I can get only for the one item. So I just put here the 0. It means that it struck only for the first item. 0 refers to the first item. So here it is only for the one item. So I put here the 0. So now click to the run. You can see. In this time it struck only for the value. You can
Why
see.
we didn't put minus 0?
This one.
2. Oh, again. Okay.
Okay. So in this time you can see again I explain. Suppose you can say I simply remove the function. In this time I can get the result as a dictionary. You can see dictionary. Okay, dictionary computing. But in this time, I need only for the NDVI minimum value. Okay.
I
So
see.
for that, I simply use a function, this function values. So in this time, from this dictionary, it extract the values and get zero. Get zero means that here the zero is the first item. Suppose this is the, you can see it is the first only for the one item. Okay. So in
Yes.
the JavaScript programming, one is considered as a zero. Okay. Zero refers to the first item. So that's why I put here the zero.
Okay.
And now you can see when I click the run, I can get the value without dictionary. Okay, I can get only for the value. Okay, and it's a number. Okay, it's a number. This value as a number. So that's why I just simply use a function in here, ee dot number, and parenthesis, and also close this parenthesis. Just close this in here. So now it considered as a number, and this number I use in my equation for fractional vegetation. Now do for the same things and calculate the maximum NDVI. So for that, I simply copy the same code and paste here. I just simply put the same variable name, suppose max max, and also put here the suppose max max, and also simply print the max value. So just put here the max max. So now click to the run. You can see what happening this time. In this time, it calculated the maximum NDVI value for this study area. Okay, here I can get the 0.4. This is the maximum NDVI value for this study area we can get. So here I calculate the mean and max. If you want, you can also put the some notation. Suppose I put here this. This is the I put here the suppose minimum NDVI. Just put the notation look like that. It also better, so anyone can easily identify what is the minimum and maximum NDVI, and put here the maximum NDVI. So now you can see it also added. You can see minimum NDVI and maximum NDVI. Okay? So you can get the two things from here. So after this, when I want to get these two value, I can simply implement the fractional vegetation. Okay. So now what is the fractional vegetation formula? You can see the formula in here. NDVI minus NDVI mean divided by NDVI max minus NDVI mean and whole square.
This is the value that we already have it now, 0.2 and 0.4.
Yes, we already calculate these things already. So now we can simply implement the equation of the fractional vegetation. So let's go. We just put here. So just I simply take a variable. Suppose I put the variable name is that suppose FV or fractional vegetation. You can put any variable name. So in this time I calculate it. So for that I can simply put here that I put the parenthesis, suppose NDVI. So I simply call my NDVI map. So here you can see this is my NDVI map. I simply copy the variable NDVI. So put here NDVI. Then NDVI minus. In this time we use here the subtract function. Subtract without minus. Subtract with mean value. Okay, so this is the mean value. And this value is stored in a variable. What is the variable name? You can see this variable name is that min, mean. Okay, I simply copy that mean. And then paste here. So NDVI subtract with mean. After that, I put here the function divided by maximum NDVI subtract with minimum NDVI.
Yes.
Okay. So just I simply call the max. You can see the max. This is the max.
Yes, here.
Simply copy the max because this variable already stored this value. Okay. I put here the max and max. It subtract with mean value. So subtract with mean value. So min, mean value. Okay. After that, after doing this thing, we have to use the another thing is that power 2. You can see this the equation is that power 2. Where is it? You can see. Yeah, power 2. Okay. We also mentioned about the power 2. So how I can do that? So for the power 2, for adding the power, we are just use a function POW. Okay, POW, put here the 2. And this POW 2 is a number. Okay. So when you want to define any number, we have to use a function e dot number and then put here the 2.
Sure.
It is the better.
Mm.
So put here the e
Yeah.
dot number, then put here the 2. Then it's the power 2.
Okay.
And then I rename it. I put the rename. So I just put the rename as a, suppose I put this name is that FV or fractional vegetation. So now my
Yes.
fractional vegetation is ready. So now display the layer. So just I put here the map dot add layer and FV. Click to the run. So now it shows the fractional vegetation of layer we can get in here. Okay, so I can get the fractional vegetation in this time. Okay, the fractional vegetation we can get from here, you can see. Okay, if you want, you can add the color. Suppose I put the color, such as, suppose I put here the mean. And if you want to simply, or if you want, you can simply click on here, you can see the layer. And you can also add the color from here. Suppose I custom 98%. Okay, it added this type of things from here, and then I simply add the pileted. You can see the plus button. Click on the plus button. Suppose I show the low value. I want to show the low value as a this type of blue, this color, and then also I put here the suppose this type of this type of white color I want to show. Suppose greater than, I simply put here the this type of color. After that, I simply put here the suppose this type of similar. Okay, 3 color we can use in here. After that, I simply apply it. So now this color is set with our map. You can see it's set it.
To make the land surface temperature, we need this fraction vegetation, right?
Yes.
Minimum and maximum value.
Yes. We just follow this algorithm, okay, which I show you that. And finally, we calculated the all of those things. We are finally calculated the land surface temperature.
I see. Okay.
So now we can get the fractional vegetation. Suppose I use this type of visualization, no problem. You can use any visualization and import that, and then simply suppose copy from here this variable and paste in your object. And then give a layer name, suppose FV or fractional vegetation. Okay. So now it's done about the fractional vegetation you can calculate. So now in this time, we are just moved to the third step. Okay. So in this time, we talk about the third step. In this third step, we talk about that thermal band. Okay. Which is the brightness temperature. Okay. In this time, we talk about these things about, we can see this band. Okay. So band 10, okay? Thermal infrared band. So in this time, how you can easily make the brightness temperature from that thermal infrared band, we calculate about that. So let's go. So in this time, third step, we talk about that thermal band. Thermal band. This band also called the brightness temperature. We can get thermal band with brightness temperature. Brightness temperature. Okay. So in this time, I need to call this thermal band. So for that, I simply take a variable. Suppose I put a variable. I put the variable name, suppose thermal. And in this time, this thermal band comes from my satellite image, which I already add. So this thermal band come from this image. So here you can say I already make a variable image. Okay, so basically this variable image contains all of those band. Okay, so from that I select the thermal band. Yeah. So from this image, I just select the thermal band. So just I simply use a function, select function, select and select the thermal band. And what is the thermal band name? You can see. You can get it from here. STB10. I simply copy. STB10. And then paste here. Okay.
Which is reflect the surface temperature.
Yes. I simply paste here. So now here we can get that. And now we also need to reproject it, this band value. ST band value, we need to reproject it. For the reprojected, you can see they are already provide the scale. So this is the scale, and this is the offset about that. This is the scale, and this is the offset. Okay. So for that, we just simply multiply the scale value and also add with the offset value. Then we can get the proper pixel value of thermal band. So for that, I simply copy this value, simply copy and go to my code and then put here that multiply. So just put here this variable multiply. So multiply with this value as well as also add the offset. So add offset value is that 149. Simply copy and paste. Okay. So now we can get the proper pixel value of thermal band. So now display the result. So just I simply use here map dot add layer and add the thermal band. Simply copy thermal. Okay. Simply copy and paste and click to run. So now it added the another layer about the thermal band. You can get this type of color. If you want, you can also simply click on here and set the color about that. Suppose state 98% and apply. So this is our thermal band we are using here. So then simply import that and simply copy this variable and paste and then give a variable name, suppose thermal. So now it's set it. Okay, so it also done about that. After doing the thermal, we have to move to the fourth step. In this time, we talk about the emissivity. So in this time, we talk about that fourth number step. Please talk about the
emissivity.
Okay. So in this time, we have to know about the formula about that. Okay. So in this time, you can see I simply go to the paper about that. In this time, land surface emissivity is that radiative properties of object. It characterizes the ability of the body emit the radiation. Okay. In this time, here we can get the two types of formula. One is the town. You can see town. So mainly urban area. We have to use this type of formula.
I see.
And this is the natural. So this is the another natural, only for the natural body, such as water, vegetation,
Forest or
forest,
something.
this type of things. So in this time we are using this formula about that basically urban. So in this time we have use this formula. So in this formula we can get some constant value. So this is the constant value. Also this is the constant value, and we already calculate the fractional vegetation. Okay. So let's go about that. We write the code for that emissivity. So for that, I simply suppose take a variable. I take a variable, suppose em, and I call the fractional vegetation. Okay, so I already calculate the fractional vegetation. I simply copy and paste this fractional vegetation. Multiply with this value. You can see fractional vegetation.
Yes.
I just simply copy.
Same value. It's a fixed value, right?
Yeah. Yes. After that, I just simply add with this value. Suppose in this time, this add with this value. Or if you want, you can also rewrite, no problem about that. In this time, first time I put this, and second I put in here. Okay, no problem about that. In this time, I simply put here the add with this value. Okay. So now in this time, here we can calculate EV. EV in this time, I also put this rename. Suppose I put this rename as EMM or emissivity. In this time, I put the EMM. So now I just simply show the result about that. So just I simply add here the tab dot add layer and call the EM. Okay. So now click to run. In this time, it also show about the surface emissivity we can get from here. So you can get this type of things. So just I simply click on here.
Changing the color.
Suppose it's 98%. Now we can get the variation about that surface emissivity. Then import that. Simply copy. And paste. And finally put here that it's a EM or emissivity. You can get from here. So now it's done. And now we talk about the fifth number of step, which we calculated the LST. So fifth LST. In this time, for calculating the LST, we have to put the formula. So basically, okay. So in this time, land surface temperature. Here you can see this type of formula. One window formula. In this time, I put in here. And so let's go about that. We write the formula one by one. So for this formula, we just simply take a variable, suppose LST. Take a variable LST and then call the thermal band. Okay. So basically in this time I call the thermal band. I already make the thermal band. You can see thermal. Simply copy the thermal and paste here. Okay. And then use a function. This function called the expression. So basically this it also calculate about that a formula about the LST.